introduction to machine learning. So it starts like this. So what is machine learning? How machine learning works? What is the workflow? And then what are the different types available within machine learning? Okay, like that. And then what are all the crises? What are all the problems? How we can come up with a problem? What's the solution available in the market? So we'll discuss all those things. So let us start with what is machine learning. Okay, you may have heard about machine learning a lot many times. And nowadays in the world, everyone aware of machine learning, at least by some way. Either they want to work in machine learning, but they're aware of the machine learning because it's a big thing. Or it's kind of a new technology. So let us define what is machine learning, how it is different when compared to the programming. Machine learning is basically learned from something which is explicitly not programmed. Okay, so for example, think in this way: you take some requirements. Okay, so assume that you want to give some input, and you want some performance. You do something, and then you want some output. Okay, let us define like this. Okay, so you have an input, you have an output. Okay, your input is salary, and our output should be PF, Provident Fund. Okay, so now think about it. Okay, so the requirement is you get the input, okay, and then you have to convert, you have to find output which is PF. Okay, this is what you have to do. Basically, to achieve this, you have to program. Okay, so how will program? You'll write a simple function. If it is Python, you'll write it like this: define function 1 or function. Okay, so the arguments will pass like this. The argument is salary because that's the one you got as the input. Okay, and then you'll PF is equal to, okay, point, assume that 10% of salary, so 0.1 into salary, because the PF is 10% from the salary, right? That's what I did. And then return PF. Nowadays people call software 1 and software 2, right? So let us bring this way. Okay, so the one is conventional programming. Okay, conventional state, it's if you want to explicitly program this logic, this particular piece, you'll write some language. I use Python here. Okay, so I pass the input to the function, and then there I'll perform some operations, very logical operations. Okay, a 0.01 into salary, and then return PF. Okay, so anyone can call this. Maybe someone is calling from the front end. Okay, so they get the salary of the user, and then when they get the salary, they call this function return PF, and then they can show it to the user. Okay, in the front end. Okay, so you can think in many ways. Okay, so this is the normal programming, right? If I achieve the same thing, okay, if I achieve, then you can ask a question: can I achieve the same thing without programming? Why I need programming? I don't need programming. Okay, can I achieve the same thing without programming? That's the question. Okay, the answer is yes, we can. Okay, because we have the data, and we have the we have the input, we have the output. Okay, so can we apply some mathematical function, and can we achieve the same output, or can we achieve the same functionality without explicitly programmed? Okay, yes, we can achieve. Okay, so using machine learning, I don't do any program. Instead, I use a mathematical function. Okay, so instead of a logical function, I'll use mathematical function, and I can achieve the same result. Okay, so that is machine learning. Okay, so if I don't use a conventional programming, okay, instead I'll use a mathematical functions. Okay, otherwise you can say that I wouldn't use logical function. Instead, I'll use mathematical function and get this output. Okay, then you can ask me, see, already we have one method, logical programming. Okay, that is very simple. Okay, that is not mathematical, that is pretty logical. So anyone can understand, anyone can do this. Then why I need to go with mathematical? Okay, so what is the need? Okay, because mathematical is little tough. Okay, most of the people cannot understand this. Honestly, why I need to take this? That's the answer, right? So you should have a pretty decent amount of advantages in case of mathematical function over the logical function to believe this. Okay, that's what we're going to see. Okay, so till now understand this. We know input, we know output. Okay, and then we have to apply some logical function. Okay, and then we need to get the result. Okay, instead logical function, I'll use mathematical function, I can get the same result. Okay, that's machine learning basically. So without explicitly programmed, okay, you'll achieve the output, okay, for the corresponding input. That's nothing but machine learning. You can see that that's the definition they give. Okay, so now how machine learning works. Okay, so now see that how this thing will work. Okay, I'll give input, I get output using mathematical functions. Okay, but that's pretty weird. How we can get that? How a mathematical function achieves this output? Okay, simple. Okay, now how a mathematical function? Okay, I write a function. A function is output is equal to. Okay, I'll write here. Output is equal to 0.1 into input. Okay, see this is my function. Okay, so what I did, output is equal to 0.1 into input. Okay, so whenever I get the input, I'll just go with this mathematical function 0.1 into salary, which is equal to PF. Okay, instead of explicitly programmed, I'll come up with a mathematical function. Okay, so what I'll do, whenever I get the input, okay, I calculate against this mathematical functions and then I'll get the output. Okay, so you can ask me, what is the advantage? Okay, so why we need to go with a mathematical function instead of a logical function? So logical function cannot handle so many things, okay, like mathematical functions. Let's take this example. Okay, okay, assume that this logic is pertaining to one company. Okay, and now the company said, the company changes the policy in such a way that out of 1%, out of 10%, okay, 5% of PF will be paid by the company and 5% by the employee. Okay, they said, okay, so now you can say let's put 5%. Let's deduct 5%. Okay, instead of 1%. Okay, so think like that. Okay, so now we have to redefine our logic. So what we'll do, you have to go to the program again. You have to redefine the logic. Okay, and then again they said, okay, so that offer is over. We change the policy again deduct 1%. Then what I'll do, again I'll go to the program, I'll change it, I'll promote it, then I'll do this. Okay, so here the nature is, okay, this logical function, okay, doesn't change with respect to the input and output. Means it's static one. And whenever customer side or we noticed the changes we needed, okay, so we'll manually calculate the functions and then we'll replace in the programming. Okay, so but in case of mathematical function, okay, this is mathematical function, right? We'll write an algorithm, okay, to define this mathematical function. So obviously we are not deriving this mathematical function. Algorithm is going to define mathematical function. Okay, so simple. So here this algorithm notices this data, which is input and output. Okay, and whenever there's a change in the input and output, this will change the function automatically. For example, assume that now we are deducting 10% from the salary. Okay, that's the PF. Okay, so assume that that's the that's the input basically. So I'm getting 10,000 as a salary. So 10% is basically 100 rupees. Okay, and then I get 2,000 rupees, 200 rupees. Okay, so this is the input I was getting. Okay, so what my algorithm will do, okay, it takes this input and output, okay, and it sees that, okay, the input is 1,000 and the PF is 100. input is 2000, PF is 200, then the mathematical function should be like this. Okay, it derives the mathematical function. Okay, so this week, okay, they changed the entire thing. Okay, so means the input, when the input is 1000, then the PF is 50. When the input is 2000, then the PF is 100. Okay, so now the data is changed. Okay, this is the data we got now. Okay, what this algorithm will do, okay, it sees the data. Okay, it understands that, okay, there's something happening. Okay, so we have to redefine the mathematical function. Okay, it does by itself. Simple. Okay, so this is one advantage. So what machine learning will do, okay, so it will have algorithm, okay, and then algorithm would be sensitive to the data. Okay, so it will have algorithm basically. Okay, algorithm would be very sensitive to that. Means, okay, so algorithm will define the mathematical function. Okay, and then whenever based on the data, okay, not based on logic, based on the data, okay, based on input and output, it will come up with a mathematical function. Okay, and whenever it sees the changes in the data, input and output, it automatically changes this mathematical function. Simple. Okay, but in case of logical, means in case of programming world, okay, someone has to sit. Okay, we call the guy as a business guy, a business SME, or whoever it is. Okay, so there's a business people. He will validate the business data manually. Okay, or he'll go to some person. Okay, otherwise this might be a government data, so he knows the rules. Okay, he will tell us to the developing team. Tell us, okay, this is how the business logic. Okay, and then this is how we have to come up with a function. Okay, then what developer will do, he'll come up with a function and then apply it. Someone will test it, and then finally this will be implemented in production. Okay, suppose if the business guy doesn't notice the change, okay, so might be, he might not follow the government rules, or he might not follow the data. If he forgot anything, then obviously the developer wouldn't have a chance to know this. Okay, then no one will change this. After some days, business will notice this. Okay, then developer will change this. Okay, he has to go to the archive and change the archive data as well, because he missed 2 days. Okay, so this is one thing. Okay, this is one thing. Okay, so what the one advantage in case of machine learning is machine learning has an algorithm. That's the core, that's the heart. Okay, and then that algorithm will take care to derive the mathematical function automatically. Okay, whenever there's a change in the input and output, okay, it will automatically change the mathematical function. So we no need to worry about anything. Okay, simple. Okay, and what is the second advantage then? Okay, so everyone understand this, right? A very simple thing. Okay, what is the difference between conventional world as well as the machine learning world? Okay, and then we'll go to the second example. Okay, so I understand this. Okay, so it come up with the mathematical functions. It automatically change this. Okay, but why we need this? Because see, this is a very simple thing. Okay, so already we are running this world. Okay, conventional world is quite good. Everyone is very comfortable. Even everyone aware of programming, what is happening. Okay, it's very simple. Okay, but it's a little difficult. Okay, advantage is quite good, but it is not very convincing. Okay, I understand. If business doesn't notice, then there will be a delay, but that delay doesn't affect the world, because the world is smoothly running, right, without any problem. Okay, so insurance company uses programming. We don't find any problem with the insurance. Banking company uses programming. We don't find any issues in the banking world. Okay, everything is running very smoothly. Okay, so then why we need to suddenly change into machine learning rather than the programming? Okay, now the problem comes again. Okay, the problem is now the data is more dynamic. Data is dynamic, and it is unstructured, semi-structured. Okay, it's very, very difficult to understand the data, or programming language doesn't able to process some kind of data. For example, unstructured data, unstructured data in the sense, think about images. Can program how you'll write a program to process the image. Okay, we can obviously write a program, but how we can start? Did anyone write the program? No, obviously. So it's very, very difficult to handle some kind of data. Okay, so I'm getting images as a data. Then what I can do with that data? Because it's very difficult to derive a logic. Okay, so means logically, how we can derive a logic logically. It's very, very different. Okay, and think about text data. Okay. Okay, for example, Sachin Tendulkar's very famous Indian cricketer. Okay, this is my data basically. How I can handle this data in the programming? Okay, that's very different, right? Okay, so to handle this kind of data for images, text, okay, to handle this kind of data, which is efficient. Obviously, the programming is not efficient at all because we cannot even think like how we can handle this. Very, very difficult. Okay, but in machine learning, you can achieve this. Okay, since it is a mathematical function, okay, it can achieve it. So this is the second thing. Okay, now we have very unstructured data. Data are images, data are text. Okay, and then data is very dynamic. Okay, data is changing rapidly. So to handle those kind of data, okay, dynamic and unstructured and semi-structured data, we need machine learning, because in this there is no we can say in the programming we cannot achieve at all. Okay, it is very, very difficult, but through machine learning we can achieve very easily. This might convince them. That's a good reason, because we need a tool to process images. We need a tool to process NLP text. Think about a chatbot. Okay, so you speak to the Apple Siri or Google Speak. Okay, it gets the output as a voice, and then it processes it, and then it sends output as a voice. Means it gets the input as a voice, and then it replies with a voice, with a computer voice. Okay, how we can achieve this kind of requirements? Obviously through machine learning. Okay, if you see now face verification system, image recognition system, if you go to self-driving cars, it automatically detects where the car is. Okay, it does everything with the inputs. Okay, so basically this is the second advantage. I can say this is the very most advantageous, a very convincing point why we have to go to machine learning. Okay, we got it right. So the definition is very simple. Okay, so machine learning is same like the programming. There's no differences. But programming, we explicitly programmed each and everything. But machine learning, based on the data, okay, it does by itself. Simple. So it'll come up with it has an algorithm. Algorithm derive the mathematical function based on input and output. Whenever there's a change in input and output, algorithm automatically detect those. Okay, and accordingly change the mathematical functions. Additionally, it can handle any kind of data what human being can handle. Okay, it can even go beyond. Simple. Okay, it can even replace human beings. Simple. It depends on the logic, or it depends on the algorithm. Okay, that's machine learning. Okay, a very simple logic. Okay, so what is the workflow then? Okay, so as I said, okay, so now we have algorithm. So this algorithm have some workflow, right? So what is the workflow? Okay, the workflow is, so here we define 4 stages. Okay, data preparation, training set generation, algorithm training, development and monitoring. Okay, let us see everything with this example. The first phase is data preparation. Okay, so I said for machine learning, okay, data is the input. Okay, the input and output. So data preparations is nothing but input as well as the output. Okay, that's the data. Okay, so we have to prepare this data because that's going to be the input. Okay, that's the first process. Okay, so we'll select the data, we'll pre-process the data, and then we'll transform the data. Okay, so for example, there are n number of data available. Okay, but we need to select, for example, in terms of data preparation, you have a database, okay, and that database have hundreds of features till x100. Okay, so what data you'll select? Can you select all data, or you'll select 5 data, or you'll select 10 data? Okay, there's some logic, right? So that's data preparation. So first you have to select data. Okay, so which data I have to select and how many data I have to select. Okay, you have to decide everything. That's the select data process. And the second process is you'll have to pre-process the data, which means, okay, so for example, okay, you have to pre-process some data. For example, some of the data would be string, some of the data would be numeric. Okay, but machine learning cannot process the string data. Okay, so obviously you have to convert that into numerical data. Okay, so that's a pre-processing. Okay, that's one example of pre-processing. Like that, there are many things. Okay, so right now, pre-process in the sense I have to change, the notation of data in such a way that the machine learning can understand. Okay, that's pre-processing. And then transform. Okay, so for example, okay, you have salary. Okay, but you don't need salary as an input. Okay, instead PF should be your input. Okay, so the PF is the 10% of salary is PF. Okay, so now you have the data is salary, but your input is PF. Okay, so you have to transform it, right? Okay, you have the data which is salary. Okay, but you have to calculate PF and you have to give that PF as an input to the machine learning algorithm. Okay, then obviously you have to transform. That's nothing but transform. Okay, that's the data preparation stage. And I'm telling in a very simple way. Okay, but this has in the pre-process itself there are many techniques, and then in transform itself you will find many techniques. Okay, so that's the first stage. Okay, so first we have to select the data. Okay, and then we'll see does this need any preparation. And for example, before we go for the algorithm, we need to make sure every data is correct. Okay, when the data is misrepresented, then obviously you have to change it, pre-process it. Okay, and then you'll see whether it needs any transformation, whether we have to transform the data. The one example we have seen is we got salary, but the input is PF. So what we'll do, we'll apply the logic and then we'll come up with a PF, and then we'll send that as input. We'll transform. Okay, that's basically the data preparations. Okay, this is the first stage. Okay, and then the training set generation. Okay, what I mean by, let's go this. Okay, so after I selected the data, assume that I selected 5 features, x1, x2, x3, x4, and x5. Okay, so on this I have almost 1000 data, 1000 rows. Okay, 1, 2 till 1000. Okay, simple. Okay, this is the training set data. Okay, you collected the data. Okay, data is like this. Okay, so you have x1, x2, x3, x4, x5. We call this the features. And then you'll have y. Okay, this is the target, which is the output. Okay, so this is your data. Your data has input as well as output. Okay, you have 5 number of input and 1 number of output. Simple. Okay, so we call this is features. Okay, the x1, x2 until x5 we call as the features. Let's say we can say x1 features and then y as target, or you can say x as input, y as output. Okay, so now we have collected 6 variables. Okay, 5 features and 1 outputs, and then 1000 rows. Okay, so now what I'll do, I can use all 1000 data. So what I can do, I can take all 1000 data and then give it to algorithm. What algorithm will do, it will check the input and output. Accordingly, it will come up with a mathematical function. Okay, so assume that some mathematical function. Okay, output is equal to some mathematics. We can say 0.35 into input plus 1.25. Okay, so this is the thing I get. Okay, so I take this 1000 data. Okay, give it to algorithm, then algorithm comes up with mathematical function. Okay, then how I can test this? That's a question, right? Because I need to make sure this is working fine. So I need some inputs for testing. Okay, so that's the stage, right? That's the training set preparation. So when I prepare a data, I have to prepare for training as well as for testing. Okay, so out of 1,000 data, okay, I have to define a training data, okay, and data for testing. Okay, so but I have only 1,000 data. Okay, so what I can do, 80% I can use for training. Okay, 80% of data, which means 800, and the remaining 20% I'll use for testing, which is 200. Okay, so instead of 1,000, I'll use 800. I'll give it to the algorithm. Then algorithms derives the mathematical functions based on input and output. Okay, so assume that this is the function. Okay, output is equal to 0.35 into input plus 1.25. Okay, so now what I'll do, okay, I'll take this 200 data. Okay, in this 200 data, I'll have x1, x2, x3, x4, and x5. That's my input and y. Okay, so let's assume like that. This is my testing data. Okay, I have x value as well as y value. Okay, now I'll take the test data. Okay, I'll take the features alone, means input alone. Okay, I'll substitute to this formula. I'll substitute my input in this formula. O is equal to 0.35 into input, because I already have input, plus 1.25. This will predict some output. Okay, I'll write it here, y hat. Okay, assume that the output is, it's predicted 5 exactly. Okay, then I'll take the second input. Okay, I'll give it to the formula. It will predict 7. Okay, it predicts 7 again. Okay, so now you see that while testing, okay, this is my testing data. Okay, so what I did, I give x to this mathematical function. Okay, it calculates y hat. I already have y. Okay, I already have y. So I have actual y as well as a predicted y. Okay, then what I'll do, I'll just take the actual data and the predicted data, then I'll subtract it. Okay, y minus y hat. Okay, it gives me the difference, right? Okay, it gives me the difference between the actual output and the predicted output. If this y minus y hat is 0, okay, so we can as of right now, we can call this as loss. Okay, or differences. Let's use a simple word, differences. Okay, differences between the actual as well as the predicted output. Okay, if the difference is 0, means then y and y hat are exactly same, then only you can get 0. Okay, if it is 2, then there is some differences, it's not good. If it is 10, then the difference is huge. Okay, so through that, okay, using the testing data, you can understand this. Okay, what's my differences, whether my mathematical functions is correct or incorrect. Okay, so if the difference is 0, then you no need to do anything. Okay, the mathematical function is exactly correct. Okay, so when it is 2, then you need to little worry about it. When it is 10, then you have to worry. You have to seriously look into this. This is called training set generation. Okay, so after we prepare the data, okay, so we prepare 1,000 data, and then we split 8:2 ratio. Okay, we split the training data by 8:2 ratio. So we give 80% to the training data set, and then 20% to the testing data sets. Okay, so using the training data sets, we come up with a function. Okay, and then using the testing data sets, okay, so we'll just keep the output, give the input, get the predicted output, and then we'll calculate the differences between the predicted as well as the actual output. Okay, that will tell us, that difference will tell us whether whether we can trust the model or we have to train a lot, or otherwise we have to change the model. Okay, and then what is the third stage? the algorithm training, we already speak about it. Okay, the algorithm training is this part. Okay, so algorithm will train by itself and then comes up with a function. Okay, so we can call this function as a universal function. So and then development and monitoring. Okay, so after that, based on the differences, and then you find zero differences. Okay, you deploy this model into production. Okay, then you have to monitor whether this is working correctly or not. There are so many monitoring methods are available. We'll see that. Okay, so right now monitoring is one of the part. Okay, so now we talked about algorithm, right? Okay, training and algorithm. So within algorithm, there are 4 types. Okay, supervised, unsupervised, reinforcement, and semi-supervised. Anyway, this semi-supervised joined recently. Okay, so before that, in maybe in web or some books, you can find only 3. Okay, supervised, unsupervised, and reinforcement. Okay, this reinforcement and unsupervised also, it doesn't have much development. Okay, so it is still developing, and then supervised has very it has some maturity. Okay, it has, in supervised world there are many algorithms. Okay, there are many breakthroughs has been achieved, but in unsupervised and reinforcement still people are working on that. Okay, we didn't get much breakthrough. Okay, in semi-supervised, as I said, it's a new term. We'll discuss about it. So now we'll discuss one by one. So what is supervised, what is unsupervised, what is reinforcement, what is semi-supervised. Okay, let's take this motivating example. Okay, so we already have some examples within it. We'll just try to understand things from this example. Okay, the supervised is just understand the term. Supervising in the sense, okay, someone is supervising me. Means someone is telling me that you're right, you're wrong by this way. Okay, that's what differences say to me. So what differences, through differences I can understand whether I'm deviating or whether I'm correct, or whether I'm deviating small, whether I'm deviating large. Okay, or it doesn't make sense at all. So someone is supervising, right? Someone tell me the differences, and from the differences I get to know that, okay, I have to change function accordingly. Who tell the differences? Okay, I predict the y hat, but since I have y, I can get the differences. Okay, so when I have the target in my input, in my data, okay, when the data has the target, then that is nothing but supervised. Simple. So I have the futures, I have the input as well as the output. Okay, so then what I'll do, based on y, okay, I can change the algorithm. Someone is supervised. Okay, otherwise you can define like this. Okay, you have x and you have y. So your formula is x and y. Okay, your algorithm, your mathematical function is x and y. Okay, means what I mean to say, okay, this formula is derived based on both x and y. Okay, it takes x and y value into consideration, and it comes with the mathematical formula based on x and y. Simple. Then we'll discuss that, and then we'll take this y for calculating differences, and when the difference is 0, we know that the model is good. When the difference is 0, 2, I'm sorry, when the difference is 2, little deviation. When the difference is 10, it's a high deviation. Those things also, okay, we'll define by using y. So when your data has both x and y, okay, and you're going to use y in your algorithm, okay, and your testing process, okay, then that's nothing but supervised algorithm. Simple. Okay, you can take this example. Okay, input is salary, output is PF. Okay, I'm giving both things as a data, and then you come up with a mathematical function. That's nothing but supervised. Okay, as simple as possible. So now we'll discuss about unsupervised. Okay, I hope everyone are clear about supervised. Okay, it's very simple. Okay, so you see the data. When the data has both input and output, and you're going to make use of both input and output, then that is nothing but supervised. Okay, then what is unsupervised? Okay, so you understand, right? Unsupervised is not supervised. So when you don't have the target, when you don't have the supervision, okay, when someone not telling the differences, then obviously you cannot, that's obviously it's very difficult. Okay, that's nothing but unsupervised. Okay, so when you have the data, but your data contains only inputs, means only futures. Okay, output is missing. then that case is unsupervised. Okay, that's the second type of algorithm, unsupervised algorithm. And what is the third type? Reinforcement. So reinforcement is, think about this scenario. Okay, think about the real world. Or think about the game right now. Okay, take some games. Okay, so what reinforcement learning will do, it will learn a policy. Okay, it will through this data, it has also input and output. Okay, so it basically comes up with a policy. That policy will tell us what action we can take based on the environment. Okay, think about the stock market. Okay, so you take a guy. Okay, take an agent. Is a stock market agent. Okay, agent who is working in stock market. So he has some 10 clients. Okay, so this 10 clients will directly invest money to the agent. Okay, and then agent has to see the stock market. Okay, and accordingly he has to invest the money. Okay, the client's money. That's his duty. Okay, so now what he has to do basically, okay, he has to assess the environment, means assess the stock market environment. Okay, what is the Tata Steel price? What is the Reliance Industry price? How it is changing day by day? Okay, he has to assess everything. Okay, that's our input. Okay, so and then okay, he'll invest it. Okay, he said he assessed, and then he thinks that okay, we can invest in Tata Steel, so we'll get more profit, we'll get more benefit. So obviously he'll get reward. Okay, when he gets more benefits, that's a positive reward. If he gets the loss, means then that's the negative benefits, negative rewards, we can say. Okay, so he has to assess the environment. We can say that as a state. Okay, and then he'll invest, means he needs to take some actions. Okay, investment is the action. Okay, and then he get rewards. Okay, so he assesses the state of a stock market, and then he does some actions. Means the action is simple. I'm going to invest in Tata Steel. Okay, for that he'll get rewards. After 10 days or after 20 days, he comes to know that okay, this is a benefit, this is not a benefit. Okay, so so now you have three things. Okay, state, actions, and rewards. And what our algorithm should do, okay, based on it should assess the state, takes the action, okay, monitor the rewards, okay, and then accordingly it has to define the best action based on the rewards. For example, I'm investing in Tata Steel. Okay, I get 10% reward, means I get 10% bonus or 10% of profit. Okay, within 10 days. Okay, that's one action. We can define that as action 1. Okay, I'm taking action 2 as well. I'm investing in Reliance Industries. Okay, I'm getting 25% profit within 5 days. Okay, so what I did, I assessed the state, okay, and then I randomly choose some actions. Okay, I get rewards for this. Okay, so when I choose action 1, means I'm going to invest in Tata Steel, I get 10% reward. Okay, the action 2 is I'm going to invest in Reliance Industries and I'm going to get 25% reward. Okay, so obviously what action I can take next time? Basically, it's better to take A2, right? Okay, simple. Okay, and the same thing when there's a rain. Okay, so it might not be logical, but just for motivation, we take this. We have a rainy day. Okay, that's basically the state. Okay, that's the environment, right? Okay, we have a rain. Okay, that time investing in Tata Steel. Okay, I get 10% reward. Okay, within 10 days. Okay, or 1 day, the rainy day particularly. Okay, so when I invest in Reliance Industries, then I get minus 25% loss. Okay, I'm not getting any benefit out of it. Basically, I'm losing 25%. Okay, then okay, you'll assess the state when the state is, when it is environment, means when it is rain, okay, then obviously you'll invest in A1. If you'll invest in Tata Steel, then you'll perform action A1. Simple. So what reinforcement learning will do, okay, it obviously basically gets three things from the user: state, and then action, and then reward. Okay, and it comes up with a policy, okay, that will tell us what action we should take based on rewards based on state. Okay, so means what action I have to take based on state. Okay, so here the input is state, okay, the output is the reward. Simple. It's same like supervised problem. The input is the state, output is the reward. You know, when I'm in the state, I'll get this reward. When I'm in the state, I'll get this reward. But what the point is, the one point is, we have action in middle. Okay, so based on actions, the reward will change. Okay, so what we have to come up with a policy. Okay, that policy will tell us, okay, what actions we can take, okay, to achieve the better reward, okay, on the state. Simple. Okay, this is the reinforcement learning problem. Okay, so even you can think about robotics. Okay, so robotics, it is walking, right? Okay, so it monitors the state. Basically, you have, you know, robotics have camera, that's his eyes. Okay, you have a robot, okay, that basically has camera. You know, through camera it sees the world. Okay, and you know, then we'll define the actions. Okay, so you know, so assume that, you know, okay, you have a robot, okay, and you tell that whenever there's a dust in the room, then the robot has to pick that. Okay, so your environment is, means state is the room. Okay, how it will watch the room? Through camera. Okay, reward is dust or no dust. Okay, action is whether I can take, means whether it can take the dust, whether it can remove the dust or not remove, not do anything, just be idle. Okay, so now, you know, during training process, okay, robot first of all, you know, monitor the room, continuously watching the room. Okay, whenever it sees the dust, okay, whenever it sees the dust, it will take this action. It can remove the dust. Okay, but someone has to tell, hey, this is not a dust, this is, you know, rice. Okay, so you don't remove this. Okay, so whenever it takes the rice instead of dust, okay, someone has to tell, someone has to give the negative rewards. Okay, so it can understand that, okay, so whenever I see the rice, you know, I shouldn't take, you know, any action. I shouldn't disturb rice. Okay, and it, next time, you know, it sees the dust, okay, and it remove the dust. Okay, someone has to give positive reward. Hey, yes, you pick up correct. You know, that's the dust and you removed it. That's good. Okay, so you can keep the same action. Okay, so that's how some, you know, this is basically the state reward and action. Okay, so then algorithm, reinforcement learning algorithm, make use of state, rewards, and action, and comes up with a policy. Okay, that policy will tell to the robots, okay, so when you are in this state, you have to perform this action. Okay, that's what reinforcement learning is. Hope you understand this. Okay, so I hope you understand supervised, unsupervised, and reinforcement learning. Okay, so let us redefine that again because this is important. Okay, so supervised is, okay, I have data, okay, I have both input as well as output, then that is supervised problem. Okay, when I don't have output, I have only input, then it is an unsupervised problem. There is no one to tell us whether it is correct or wrong. Okay, no one can assist this. Okay, and no one can supervise it because we don't have target. Okay, that is unsupervised. And reinforcement problem is, okay, it's the same like supervised. Okay, we have someone to assist. Okay, so someone needs to tell what is the reward for action. Okay, so there's a state, that is input, there is a reward, there is an output. Okay, but that reward will keep on change based on the action. Simple means there is no single reward. Okay, so if you see a supervised problem, there's a single reward. There's only one target for the input. Okay, but in case of reinforcement learning, we have only one input, which is state, but we have so many outputs, so many rewards. Okay, so how we can get the best reward? Okay, so we have to define the action. So that's reinforcement learn problem. Okay, instead of input and output, instead of features and target, you have state, rewards, as well as action. Okay, so based on this three, we have to come up with a mathematical function, which is a policy. Okay, that will tell us, okay, when I'm in the state, what actions I need to perform. Simple. Okay, and the last thing is semi-supervised. As I said, this concept is recently emerging. Okay, it means they recently give a definition for this concept, but this concept, so many people use this concept in so many fields. Okay, so now think about it. Okay, you have 8,000 data instead of 800. Okay, and some data you have target, and for some data you have Y, for some data you don't have. Okay, so assume that out of 8,000 data, okay, so out of 8,000 data, 5,000 has target. Okay, and 3,000 with no target. Okay, so out of 8,000, 5,000 has target and 3,000 has no target. What we can do then? Okay, so to train this, we need a target. If we don't have target, we cannot train. Okay, so semi-supervised is multiple techniques. It's simple. The logic is, okay, so out of 5,000, 5,000 has target, that has and 3,000 doesn't have target. What we can do, okay, somehow we can generate the target for this 3,000 rows and we can make use of it. Okay, what I can do basically, I can take 5,000 as a training data. Okay, I'll train it. They'll come up with a model. Model is nothing but a mathematical function. Okay, then what I'll do, anyway, I have input for this 3,000, right? Okay, I don't have output. I have to, I have to predict the target. Then I need to use this 3,000. Okay, so what I'll do, I'll take the features and hit the model. That will give me the target. Okay, I'll make use of those target. Okay, so what I'll do, I'll fill the target for the remaining training data. So I'll get the target. Okay, so now all my 8,000 has target. So I can use this 8,000 as a training data. Simple. Okay, so anyway, you have to apply supervised as unsupervised or reinforcement algorithm. Okay, but the point is, okay, so I have data, I have 8,000 data, 5,000 has labels and 3,000 doesn't have labels. Okay, so what I can do, I can make use of this 5,000 data. I can make use of this 5,000 data. I'll apply a supervised algorithm. I'll come up with a model. Okay, then I'll take the 3,000 data. I'll take the input. I'll hit the model. I'll get the target. I'll make use of those data. Now my all 8,000 data has input as well as output. Means has features as well as target. Simple. Okay, so this is the machine learning algorithm types. Okay, so we have 4 types basically. Okay, supervised, unsupervised, reinforcement, and semi-supervised. Based on data and based on requirement, okay, we'll choose any one. Okay, so within supervised, there are many different algorithms. Within reinforcement learning, there are many different algorithms. Okay, so we'll see one by one. So now we have seen what is data preparations, what is training set, okay, and then what are the different types of algorithms. Okay, now choosing an algorithm. Okay, so as I said, within supervised, we have different types of algorithms. We have linear regression, we have logistic regression, we have support vector machines, decision tree, random forest, we have so many things. Okay, within unsupervised, you have k-means, you have hierarchical clustering, you have partition clustering, okay, you have nearest neighbor, you have so many, you have different types. Okay, so within reinforcement learning also you have, deep Q learning, double deep Q learning, Monte Carlo, temporal difference, dynamic programming, we have so many different types. Okay, so how I can choose this? Okay, let's take supervised. Okay, within supervised, assume that you have 10 different types of algorithm. Okay, so how I can choose the particular algorithm? Okay, on what basis? Okay, that's very important, right? Okay, based on, okay, so we'll see one by one. Okay, the one thing is accuracy. Okay, if you see the supervised thing, we'll calculate the differences, right? In one example. Okay, we'll calculate the differences and that difference tell us the loss. Okay, if it is 0, then the actual and predicted is exactly matching. So it gives the maximum accuracy. Okay, so obviously through differences. Okay, so we denote it in a machine learning sense. Okay, so instead of differences, we can call that as a loss. Okay, so if we have a loss function, okay, and that will tell us the accuracy of the model. If it is 0 loss, then it is 100% accuracy. Okay, if it is so based on through the loss we can calculate the accuracy, right? Okay, so if my accuracy is 100%, okay, this model is fitting 100% well. Okay, so based on accuracy, I can tell how whether this model is good or not good. Okay, so that's one important factor. So if I know the accuracy, then I can tell that okay, this model is good, this model is not good. Okay, for an example, we have a supervised. Okay, let's take an example. We have a supervised problem. Okay, we have a data. It has both input as well as output. Okay, I apply logistic regression as well as support vector machine. Okay, so when I apply logistic regression, I get 90% of accuracy. And then when I apply support vector machine, which is SVM, I got 95% of accuracy. Okay, so logistic regression gives only 90%, but support vector machine SVM gives 95%. Okay, so which is more accuracy? Basically SVM. Then I'll choose SVM. Okay, that's one factor. That's one other factor. Okay, and then the second thing is training time. Okay, let's take the same example. Logistic regression takes 5 minutes, and SVM takes almost 5 hours to train the data. Okay, so and one more point is I have only 16 GB machines. Okay, logistic regression runs in 16 GB machine. Okay, but support vector machine doesn't run. Okay, so for that I have to use 32 GB machine. Okay, so the one thing is training time. Okay, so how many training time it requires. Okay, so I'm okay with accuracy. I'm okay with 90% accuracy, but I'm not okay with 5 hours of training. Okay, that time I can choose logistic regression. Even though it gives me less accuracy, I'm okay with the training time. It takes only 5 minutes, but SVM takes almost 5 hours, and it has some missing requirements as well. Okay, so that's the training time. How much time it is taking training. So accordingly, I choose the algorithms. Okay, and then there's something called linearity, non-linearity, and then linear and non-linear class boundary. Let us discuss that. Okay, so the linearity and non-linearity is again a big concept. Okay, so first we'll explain one by one. Okay, what is linear basically? Okay, the linear is a predictable. Okay, let's open some whiteboard. Because it's important. Okay, let's take this line. Okay, this is my X, my input, and this is my Y, my output. Okay, assume that it has some reading points, 1, 2, something like that, and then Y also has 1. Okay, so when you plot the point, okay, so you have X and Y value. When see this Excel, okay, you have X and you have Y. When the X is 1, Y is also 1. X is 2, Y is 4. Okay, this is your data. Okay, now what you'll do, okay, you see this, when the X is 1, Y is also 1. So what you'll do, X is 1, Y is 1. When the X is 2, Y is 4. Otherwise, let's put 0 and 1. Okay, we'll take the classification problem. Simple. This is an example. Okay, we have so many X and Y. Okay, and Y has only 2 possible values. Okay, 0 and 1. Okay, when the X is 1, it is 0. When the X is 2, it is 1. So if you see that, this is the point value. Okay, so what we'll do, okay, so we'll give a point to this. Okay, this all belongs to the data where the Y is equal to 0. Simple. Okay, if you see the Excel, Okay, you have y is equal to 0 as well as y is equal to 1, right? And these are all the data belongs to y is equal to 0. Okay, now, okay, these are all the data belongs to y is equal to 1. Okay, so when you see this, okay, I can basically comes up with a straight line between the two inputs. Okay, so y is equal to 0 and y is equal to 1 can be splitted by a straight line. Okay, this is nothing but a linear. Okay, a very simple example. Okay, what is mean by non-linear then? Okay, the non-linear is, okay, it will be here as well as it will be here as well. Okay, for this, how I come up with the decision boundary? Okay, if I need to come up with the decision boundary, I'll come up like this. Okay, this is my decision boundary. So see this decision boundary. This is fluctuating a lot. This is not a straight line. This is nothing but a non-linear decision boundary. So we take the input, we take the output. Okay, we keep input in x-axis, we keep output in y-axis. Okay, so we'll come up with a scatter plot like this. Okay, and then we'll derive the decision boundary. If the decision boundary is straight line, then that's a linear problem. If the decision boundary is not straight line, then it is a non-linear problem. Okay, so for linear, you have a formula, right? Y is equal to mx plus c. For straight line, the formula is y is equal to mx plus c. Okay, for non-linear, you have to derive the formula. Okay, so generally machine learning works well for a linear problem. Okay, it will work for non-linear problem as well, but you know it might not give good accuracy. It might not give good loss and all those things. You know, for that you have to come up with some special techniques. So generally linear problem is good. We can solve that. Non-linear problem is difficult to solve. So we have to come up with some special method. So that's the difference between decision means linear decision boundary and non-linear decision boundary. Okay. So obviously when the problem is linear, we'll choose some algorithms. Maybe we may choose logistic regression because the problem is linear. I'll choose a straightforward algorithm, logistic regression. But when the problem is non-linear, okay, which algorithm I have to choose? Maybe I may choose SVM. That's might good for non-linear decision boundary. Okay, so based on linearity, non-linearity, we can use some algorithms. But there's a question, okay, how I can find linear or non-linear? How I can find this? Okay, you give me some data. How I can find whether this data is linear, non-linear data? Okay, the one is you can come up with a plot like this. Okay, so based on the plot, you can derive whether this is linear, non-linear. But assume that you have so many x values. This is basically a two-dimensional, right? You have only one x, you have only one y. Assume that you have lots and lots of x. Okay, so this is x2, this is x3. Okay, so the dimension is going. When the dimension is greater than 3, obviously you cannot see it. Okay, so if it is a three-dimensional, then obviously you can come up with three-dimensional plot like this. Okay, x, y, and z. Okay, this is x1, this is x2, this is y. Okay, so when it is multi-dimensional, obviously you cannot see that. Okay, you cannot plot like this. Then how I can come up with how I can find whether the data is linear and non-linear? There are so many methods. Okay, we'll discuss this in future section. Okay, how we can find the linear and non-linear data, because this is important thing. Okay, I think that's all about it. So these are all some parameters. Okay, so based on accuracy, I can choose between the different algorithms. I can, based on training time, based on whether the data is non-linear or linear, accordingly I'll choose algorithms. Okay, these are all some methods. Okay, how I can choose the algorithms. Okay, and then there's two problems called overfitting and underfitting. Okay, so these are all very, very important parameters in terms of machine learning. Okay, let us discuss about what is overfitting and what is underfitting. Okay, so now you have test data and training data, right? Okay, you got the data and you split into test set and train set. Okay, so now you have training set and test set. Okay, so this is your test set, training set, right? X, Y, X, Y. Okay, let's keep X2, Y2. Simple as X1, Y1 training data. X2, Y2 test data. Okay, so assume that you have X1, Y1. Okay, using the training data, you come up with a model. Okay, so then what you'll do, you'll predict Y hat. Okay, then what you'll do, you'll compare Y1 minus Y hat 1 and comes up with a loss. Okay, this is what you'll do. Okay, so you get X1, Y1 as a training data. You come up with a model using algorithm. You'll predict Y hat 1 and then you'll subtract Y hat 1 with the actual value Y1 and then you'll calculate the loss. Okay, same thing you'll do for test set also. So you have training loss and test loss. Now the training loss is 98%, but the test loss is only 60%. Okay, so simple. You got some data set. Okay, it has 1000 rows. Okay, you split 800 to the training set and 200 to the test set. Simple. Okay, so now you come up with X1, you know, this 800 is X1 and Y1. Okay, it comes up with a model, you predict Y hat 1 and then you subtract it, you come up with a loss. Okay, when you see the accuracy, okay, you calculate accuracy based on loss. Okay, so when you see the accuracy for the training data set, it is 98%, but the test data set, it's only 60%. The model is same. Okay, so I can say this is a training data set model. Okay, training data set model. Okay, so now through that, what you can tell, okay, means the model is very good for training data. I mean X1, Y1, but it is not good for X2, Y2 because I got good accuracy when I use X1, Y1, but when I use this X2 for this model, okay, because I'll create a model using training data. Okay, for test data, I won't create any model. You know, I'll make use of the training data set model. Okay, but when I use X2 to this model, okay, it gives only 60%. So means from that I can say, okay, it generalized well for X1 and Y1, but it is not generalizing well for X2 and Y2. Okay, this is called overfitting. Means it fitted well for training data, but not test data. It's overfitting. Okay, at the same time, okay, what is underfitting? Underfitting is, okay, that's a very difficult condition again. Okay, it's fit well for training data, 92%, and then it gets 93%. Means for training data we get accuracy of 92%. Okay, but for test data, okay, let's not put like this, 65%, and then 64%. Okay, if you see that it not fit for training data itself. Okay, training data itself, it is not fitting. Okay, it gets only we get only 65% of accuracy. Okay, so for training data itself, it is not fitted well. Okay, since it is not fitted well in training data itself, why we need to look into this test data? Obviously, we can remove this. Okay, we may not see this. Okay, because it should fit well for training data first of all. Okay, when I get 98% accuracy, I can say that the training set has fitted well. Then I can go for the testing. But during the testing, I found that I got only 60%. Okay, I can found that this is a overfitting problem. I have to do something for this. But when the training error is 65%, when the training accuracy is 65%, I can persistently say that this is completely wrong. Okay, because it does not even fit well for training data sets. Okay, that's the underfitting problem. Okay, so maybe we in the later section we'll see how we can overcome this overfitting and underfitting problem. Okay, but right now this is the definition. Okay, you have training set, you'll test set, you'll compare both training accuracy as well as test accuracy. Based on that, based on the value, you'll say this is overfitting, this is underfitting. Okay, and there's a good fit. Okay, what is good fit? Good fit is, okay, I get 98% of accuracy for training data set, and for test data set, I get 97%. This is pretty decent. Okay, so I get 98% of accuracy for training data and 97% of test data. It's pretty good. I can say that I get 97% of accuracy. Okay, that's a good fit. Okay, so what you need to do, if you find the overfitting, you need to adjust something. Okay, and you need to get the good fit. Even for the same case in case of underfitting. Okay, so overfitting and underfitting is not good. Good fit is good. Okay, so what you need to do, you need to choose the algorithm in such a way that is not overfitting as well as underfitting, and it provides a good fit. Okay, this is very important. That's all about it. Okay, so RB asked the question, in real-time industry, how much accuracy is acceptable? Okay, so RB depends on the problem. For example, if you see the image recognition, okay, the industry achieves almost 98% of accuracy. Okay, for 1.2 million images. Okay, so you have 1 point means 12 lakh images. Okay, and it's a supervised problem. You have the images as well as you have the label. Means you have, you know, what that image is, whether it's a dog, whether it's a cat. Okay, they achieved almost 98% of accuracy till now. Okay, for image recognition problem. So it depends on the problem. I mean to say, you know, if you see the very old problem, means think about it. You have some raw data. Okay, you have some output, and it is linear completely. Then obviously, you know, you have to achieve 100% because it's linear, and you have all informations. Okay, then obviously you have to achieve 100%. Okay, it's a very difficult problem. Okay, you have unstructured data. Okay, and that is non-linear. Okay, and it is data is changing, you know, depends on time. Then basically, you know, achieving 90% accuracy or 95% accuracy is great thing. Okay, so right, you know, we cannot say that you know, this is the good accuracy to go with. Depends on problems. So for some problem we can say that, you know, we have to achieve 98%. For some problem we can say that, okay, the problem is little critical, so, you know, in achieving 85% is very good. Okay, so, you know, we cannot hard code in such a way that this is the right accuracy, this is the non accuracy. It depends on problem. Okay, but there is, you know, for image recognition, as I said, for image recognition problem, right now they achieve 98%. Okay, so when you do any image recognition, okay, so if you get a percentage less than 90%, okay, you can say that I didn't achieve the industry standard. I have to, you know, train it, and then I have to achieve the industry standard. Okay, so every problem has an industry standard. Okay, so image recognition is 98%, NLP is 92%, something like that. Chatbot. Okay, so there's an industry standards. We call this a Bayesian error. So we have a human error, right? Okay, and then we have test error. Okay, this is the one we calculate, right? We calculate the training error and test error. Okay, so when I get 98%, when I get 98% here, okay, I can say that, okay, I have a problem. Okay, that problem means I have a data. Okay, apply algorithm, and then for training error I get 98%, test error I got 98%. Okay, my accuracy is 90% then. Okay, but what is the industry standard error for this data? Okay, this might be a problem, this might be a prediction problem. Okay, in industry, okay, for this the industry standard would be 99%. Okay, if you give it to human, the intellectual human, not everyone, okay, who is very good in this field, okay, we call this an intellectual human, and he can predict 100%. Okay, we call this as Bayesian error, Bayes error. Okay, so we'll get the training error, and then we'll get the test error. Okay, we'll compare with the industry standard. Okay, the industry standard is 99%, but I'm matching only 98%. There's a more room to improve. Okay, now you achieve 99%. Okay, your test error is 99. Okay, now you'll compare with industry standard. Okay, you can say that, okay, I'm matching industry standards, but human can predict better than me, 100%. So yes, thus you can improve as well. Okay, so then you can take from the industry standard. We have to apply some techniques. You have to research it, and then you need to get this Bayesian error. And if you match the Bayesian error, it is 100%. Okay, you can take this case for image recognition problem. Okay, you got the training error of 92, a test error of 91. Okay, and the industry standard is 98%. Okay, we can say industry standard is 93%. Bayesian error is 98%. Okay, now you can say that, okay, my accuracy is 91. Okay, so but the industry standard is 95. Okay, so first I have to achieve 95, then the Bayesian error is 98. Okay, so how I can achieve 100%? Okay, how I can perform better than Bayesian error? Okay, this basically the conditions. So you'll take the data and then relate it with the industry. Okay, take the industry standards and the Bayesian error. Okay, and then compare with that. Okay, this is the good way to do. Okay, this is a standard way to do. Okay, so we have talked about supervised, unsupervised, reinforcement, overfitting, underfitting, accuracy, training time, lot of things, right? Okay, so how we can apply this, okay, in linear regressions. So when we see linear regression next week, we'll take the data, we'll take the input, we'll take the output, we'll apply linear regressions in Python. Okay, we'll calculate accuracy, we'll calculate test accuracy, training accuracy, we'll see whether it is overfitting, underfitting. Okay, and then how we can use statistical technique to overcome the overfitting, underfitting problem. Okay, how we can get a good fit. Okay, so how we can perform par excellence with the industry standards, and how we can even get Bayesian error. Okay, all these techniques we'll see in later sections. Thanks for participation. We'll see you next week. Bye.
A cat killed. Average is dead.